So, good evening, everyone. So now today we will discuss about the minors and cofactors of an element of the determinants. Yesterday I have cleared the basic concepts related to the determinants, okay, and I have also told to you that how you will determine the value of the determinant of the first order, second order and third order. So now today I will clear the concept related to the minors and cofactors of an element of the determinants. So see the concept here. At first I will explain the minor, okay, and after that I will clear to you the cofactors. So see the concept. At first the minors. At first I will explain minor. Actually the complete lecture is related to the minor and cofactor. Okay, minor and cofactor of a determinant. Okay, so minors and cofactors. Here it's a cofactors of an element of determinants. Okay, this is the symbol of the determinants. Okay, let me see the camera. Yes. Oh my god, it's a light is available here. Okay, so you can understand it's a minors and cofactor of an element of determinants. Okay, so students, let's start the concept. I'm going to begin the at first I will adjust this camera. Okay, yes, it is clear to you. So first thing, what is minor? Okay, so at first I will explain the minor and I am going to describe what is a minor. The minor this is the minor will be indicated by capital M and it's I of J. It will be suffix I and J. I indicate the row and J indicate the column. Okay, the minor Mij of an element, the minor Mij of an element of, and what is the element? We can take the element, we have to take the element. So it's suppose Aij. Okay, the minor Mij of an element Aij is the value of the determinants. Right now I will write completely determinant obtained by deleting the minor Mij of an element Aij is the value of the determinant obtained by deleting the ith row, okay, ith means it's a row. This will indicate the numbers of row, okay, ith rows and jth column. Is it clear to you? See the definition. The minor Mij of an element Aij is the value of the determinant obtained by deleting the ith row and jth column of the whatever the given determinant of the given determinant. Okay, this is the symbol of the determinant I have taken here. Okay, see again the definition. The minor Mij of an element Aij is the value of the determinant obtained by deleting the ith row and jth column of the given determinants. Okay, so in this way you will find out the minor. Okay, and write down the cofactors. Right now you can write. After that I will explain the minor and cofactors of an element of the determinants, okay, within the one example. Okay, this is the minor definition, and now write down the cofactors. It's a minor, and now this is the perfect definition. And the cofactors, Now write down the cofactor Aij. It's a capital A, ith it's in suffix form, and j is also in suffix form, where I for rows and j for the column. The cofactor Aij of an, again we will take this element of an element Aij. Is it clear to you? The cofactor Aij of an element Aij, okay, it's a capital A and here is a small a. It is an element of the determinants. Okay, so the element Aij is defined as how will you define this? It's Aij is equal -1 to the power what, I plus j of mij. This is the general definition. The cofactor Aij of an element Aij is defined as Aij is equal -1 to the whole power I plus j of mij. In this way you will define, okay, the minors and cofactors. From the minor we will remove the ith row and jth column within the determinant. Okay, so now students, let's see the example. I have taken here the example. It's the definition. If you want to write, you can. So finally student, I have come with a question. Find the minor and cofactor of each element of the determinant 2, -2, 3, 1, 4, 5 and 2, 1, -3, where 2, -2 and 3, these are called the element of the determinants. Okay, so one by one I will find out. So minor, at first minor we have to find out. So minor of 2, okay, minor of element is what is your element? Minor of 2 of determinant. Okay, so this is what minor of 2 is what, 2 represent 2 lie on the first row and also the first column. So this will give you what, M11. Is it clear to you? Okay, M11, what is the M11? This means according to the definition of the minor, we have to remove the ith row. This is your ith and it is your jth. Okay, it's a first row and first column, so we will remove the first row and first column. So 2, -2 and 3, it is deleting elements, and we have to also 2, 1, 2 removed. So we will get a 4, 5, 1 and 3. It's a second order determinant here. Okay, so how, yesterday I have not told to you that how you will find out by the help of leading diagonal. I have told to you, but today I want to explain more about it. For the third order determinant I have explained how you will find out. Okay, but for the second order, how, see it, actually it's a second order. Why it is? Because it has a 2 rows and 2 columns. Okay, so because of this it's a second order determinant. And now how I will solve it? Listen students, every time it's a, I'm solving here, it's a, at first see very carefully, here is what, I am expanding this determinant along row. Okay, you can directly first, okay, at first I am going to tell you 2 methods how you will, by the leading diagonal you can solve it. Okay, so 4 into -3, this becomes -12. Okay, and 5, and it's already minus, and 5 into 1, this will give you what, -5. So it's a -17, but it's your leading diagonal method. But another method is what, see the next method, method 2. Listen, it's a conceptual actually. So see here, every time you will write -1 to the power, I am taking here the actually expand this determinant along row 1. Okay, I am expanding this determinant along row 1. Row 1 means this row, okay, where the elements are 4 and 5. So -1 to the power, here I have taken here, it's a what, 4. Okay, and 4 is lie on the first row and first column, so this becomes 1 plus 1. Okay, so if you remove the first row, same as the minor, first row and first column, you will get what, minus 3. Is it clear to you? And now again I am applying here plus minus 1 to the power, listen, now it's a next element of the first row, this will give you what, 5. Okay, so I am multiply it 5, but 5 lie on the first row and second column, so this becomes 1 plus 2. 1 is what, first row, and 2 is what, second column representation, so this becomes 5. So if you remove it, you will remove the first row and the second column, you will get what, 1. So this becomes minus 1 to the power 2 is what, it's a 1. So 4 3 ja minus 12, it's 1 into 4 into minus 3, and plus minus 1 to the power 3, this becomes minus 1 to the power 3, and 5 into 1, so it is what, 1 into 4, 4 3 ja minus 12, and plus it's a minus 1 to the power 3, this becomes what, okay, it's a minus 1 into 5 into 1, so now it's a minus 12, and plus multiply by 1, this is minus 1 into 5 into 1, so this is minus 12 and minus 5. Okay, so this is the concept actually. Because of this you are feeling that it is a lengthy. Okay, so it is, if you feel that it is easy, you can solve this way, and if you are feeling it's a conceptual, how as a teacher I have to tell you in this way you will find you will expand the determinant along something. Okay, row 1 or C1, whatever you want to take you can. So in this way you will find out the minor of 2. Okay, I will explain only 1, and after that you will find out the minor of minus 2, for the minor of 3, minor of 1, minor of same manners. Okay, so next is it's a minus 17. Okay, so now it's a method 2, I'm going to remove it. Okay, if you want to write you can. Now students, it's a time for the cofactors. Okay, so how will you, I will tell you only I will tell you for the one element. Okay, you can solve for these elements. Okay, it's your work, you have to find out. Okay, so minor, so understood everything here, how I will find the minor. And now the cofactor of 2. Okay, cofactor of, I am finding for the 2. Okay, of 2 of determinant, this will represent what, in which form, it's a 1 1. Okay, aij, so this will give you what, minus 1 to the power 1 plus 1. Okay, because it's a formula is what, aij equal minus 1 to the power I plus j of mij. Okay, ij will be in suffix form in this way. Okay, so put here, it's a 1 1 I have taken here, so the value I is also 1 and j is also 1. Okay, so a11, this will give you what, a11 is minus 1 to the power 2, this becomes 1, and m11 is already, we have find out here, it is minus 17. So this cofactor of your 2 of determinant is what, it's called a minus 17. Okay students, if you want to, now I'm going to solve. Next I want to take, suppose for the minus 2, I have taken for the minus 2. Okay, so I am going to rough this portion. If you want to write your minor for the first element, it's minus 17, and the cofactor for the first element of your determinant, it's called which lie on the first row and the first column, this is known as also the minus 17. So let's start. For the next element I will tell you, actually for the minus 2 I have to tell you, it's a minus 2. Okay, and here is also for the minus 2. So minus 2, see the minus 2 lie on the first row, so this becomes first row and the second column, so this will be removed, we will remove it, it's a 12. Okay, and now it will be changed, of course it will be changed. We will remove the first row and second column, we have to delete the first row, we will delete first row and the second column. After this we will get a 1 2 and 5 and minus 3, so this becomes what, minus 3 multiplied by 1, minus 3, and minus 5 2 is 10, this becomes minus 13. Okay, so similarly what cofactor for the minus 2 of determinant, this will give you what, it's a12, or you can write minus 1 to the power 1 plus 2 and m12. Is it clear? So minus 1 to the power 1 plus 2, this will give you minus 1, and into it's m12. What is the minor of this? It's a minus 13. So minus 1 into minus 13, this is 13. Okay, similarly, are you able to find? Okay, so this will give you now the minor of 3. Similarly, you will find out 1, 4, 5, 2, 1 and minus 3. Okay, so please subscribe and like this channel, and also if you feel better with the concept, please like it.